Wide Field Camera 3 replaces the 15-year-old Wide Field Planetary Camera 2, or WIFPIC 2, that's currently aboard the Hubble. WIFPIC 2 brought us some unforgettable images, found evidence of mysterious dark energy, and even looked back in time, almost to the very beginnings of the universe. More about that later. But with its updated technology, Wide Field Camera 3 will improve Hubble's ability to survey the universe by factors of up to 30 or more in some colors of light. We'll be detecting distant or exotic objects in our universe far more efficiently than ever before. Just imagine where the Hubble telescope will take us, the amazing sights we'll see, and the new things we'll learn about the universe.
Wide Field Camera 3 is a terrific general-purpose imager that's going to be capable of studying all kinds of fascinating objects throughout the universe, from the outer planets of our own solar system and discovering objects beyond Pluto in our own solar system, to studying star formation in giant clouds of dust and gas in our Milky Way galaxy.
You really have to hand it to WIFPIC 2. The images from the soon-to-be updated camera have transported us to some almost unimaginable places over the last 15 years. But once installed, Wide Field 3 will be able to see even more, all due to some pretty amazing advances in technology. For instance, the light that enters Wide Field 3 can be split into two separate channels. One channel sees ultraviolet and visible light wavelengths, and the other one sees infrared light. Our eyes can only see objects that radiate visible light, and all other objects are invisible to us. Wide Field 3 will be able to see the same things that we see, but also objects that radiate ultraviolet or infrared light. Through the eyes of Wide Field 3, we'll be able to record and study an amazing number of objects in space.
You picture the spectrum of colors in a rainbow, from red to orange to yellow, green, blue, indigo, violet. Ultraviolet light is even farther in the direction of violet, so shorter wavelengths than your eye can see. Going in the other direction, yellow to orange to red, the next set of wavelengths is infrared radiation, and those are longer wavelengths than your eye can see. And the Wide Field Camera 3 covers the electromagnetic spectrum over that full range, from the ultraviolet to the infrared.
So let's get back to how the Hubble telescope has helped us look into the past and actually measure the age of the universe. To find the age of the universe, astronomers needed to figure out how fast it has been expanding since the very beginning, or since the Big Bang. It's believed that this expansion increases at a constant rate of speed that they call the Hubble constant. Scientists use the Hubble telescope to zoom in and study a certain type of star whose brightness changes with time in a way that allows astronomers to determine its distance from the Earth. After studying these special stars in 18 different galaxies, and by using this newly developed Hubble constant, astronomers determined that distant objects in the universe are speeding away from us at a speed of over 80,000 kilometers per hour for every million light years they are distant from Earth. Combining this result with other astronomical data, this means that our universe was born about 12 to 14 billion years ago. So by using extraordinary tools like the Hubble Space Telescope with its new Wide Field Camera 3, science and math are helping astronomers make sense of more otherworldly questions. And this is only the beginning. A lot of those otherworldly questions will be answered by future astronomers, maybe by one of you sitting in class today.
Mathematical skills underpin all of them. You have to be able to do the right calculations, to do those designs, to make sure that your optics will work, that your electronics will work, that your structure will be strong enough. And just math pervades the whole system of developing an instrument like this.
The universe is a big place, and it's all just waiting to be explored. There will always be new discoveries to find and new problems to solve. And just maybe some of you will be there to help explore and help solve them.